Welcome to the Legacy Tree podcast. We're the team at Legacy Tree Genealogists, and this is where we talk about the real side of family history. The surprises, the roadblocks, the emotions, and the stories that don't always fit neatly into a pedigree chart. From DNA discoveries to archival finds, cultural history to personal moments, we have honest conversations about what genealogy actually looks like and why it matters. Because when it comes to preserving what matters most, you deserve to put your family history in our hands. Today, we are diving deep into the world of mitochondrial DNA, mtDNA, to find out how genetic testing can trace your direct maternal line back thousands of years. Joining us to crack these genetic mysteries is Caleb Anderson from our DNA research team. Caleb's background reads like a classic detective novel. His lifelong passion for solving mysteries led him to a master's degree in genealogy from the University of Strathclyde, and he specializes in using genetic genealogy to break through centuries of changing surnames and brick walls. Today, he's breaking down everything from what a haplogroup actually is to how mtDNA is uncovering incredible unwritten history. Caleb, welcome to the show.
Okay, so what is mitochondrial DNA?
Yeah, great question. The short answer to that is that a mtDNA test or mitochondrial DNA test is a DNA test that analyzes your mitochondrial DNA. That's a unique type of DNA, which is passed along the direct maternal line. Currently, only one of the major DNA testing companies, FamilyTreeDNA, offers a dedicated mtDNA test, but several of the others include information about a tester's mitochondrial DNA as part of their standard test.
So why would you want to test your mtDNA?
You'd want to test it to learn more about that direct female line. So it can tell you and answer questions that go much farther back in the past than a standard DNA test. So if you have questions that are specific to that line, or you just want to extend it, this is kind of the best test to do that.
So then what's the difference between a regular DNA and then a mitochondrial DNA?
Yeah, that's a great question. To answer that, we kind of have to talk about the different types of DNA. And there are actually 4 different types of DNA that are tested by these different tests: autosomal DNA, xDNA, y-DNA, and then mitochondrial DNA. So your standard DNA test, and what most people think of when they think of a DNA test, has to do with your autosomal DNA. So that's 22 of the 23 chromosome pairs that you inherit from your parents is autosomal DNA. Each parent gives you half of it, and they mix together in a process called recombination. And so it changes every few generations. And if you want to figure out for a specific ancestor how much of it you got from them, you kind of divide by 2. So 50% from each parent, about 25% from each grandparent, and so on and so forth. Mitochondrial DNA is only passed along that direct maternal line. So you have roughly the same mitochondrial DNA as your mom, her mom, and that includes any siblings or maternal aunts and uncles. So both men and women inherit that DNA, only women pass it on. But it changes very little over the course of those generations because it doesn't recombine with the other parent. So because it changes so little, we can trace it very far back in the past.
That's really cool. It's like genealogists are turning into scientists.
Exactly.
So what traits do you get from mitochondrial DNA?
Yeah, so the mitochondrial DNA, it's stored in the mitochondria, which you might remember from high school biology is the powerhouse of the cell. And so the traits that go along with that DNA basically affect what the mitochondria does. So they're very focused on energy production, building the RNA molecules, the enzymes that support energy production in the cell, and those kinds of things, rather than, say, your eye color, your hair color, one of those other traits. There's a few mitochondrial diseases that affect energy production in your body, and so that gets passed along with mitochondrial DNA. But unless you have one of those very specific diseases, you really aren't going to have a typical trait like you would get from your autosomal DNA.
That's interesting. So I've heard a bit of people talk about mitochondrial Eve. Is that a person? Who is it? What is it?
Yes, it's a hypothetical person, we'll say. And so, I mean, a real person who lived a long time ago but also a role at the same time. And we'll explain that. But basically, how we came up with this person, Mitochondrial Eve, has to do with the kind of work that researchers have done to compare different people's mitochondrial DNA with each other. So when two testers have the same mutation in the same position in their mitochondrial DNA genome, that typically means they have a common ancestor. So that formed in somebody way back when, that's a branch point in this mitochondrial family tree. And when researchers compare enough of those testers to each other, enough of those mutations, along with the testing they've done on ancient human remains, they're able to use those data points to build out humanity's mitochondrial family tree. And basically, Mitochondrial Eve is where we trace all of those data points back to the most recent common ancestor of all of these mitochondrial lines. So your direct maternal line, my direct maternal line, everybody who's alive today, their direct maternal line goes back to this Mitochondrial Eve. So our mothers, thousands of years ago. And this isn't the same thing as, say the biblical Eve in, religious circles, because she was not the only person who was alive at this time. There were thousands of other humans alive at the same time, before her, after her. But their direct maternal lines, or their female lines descending from them, all died out. So they probably have descendants alive today, but just not in that direct female line. And the reason we think of her as more of a role, or say a job description, rather than an actual person, is if we hypothetically found a new tester that had a different maternal line that was farther back, which is still happening as we test more people, then the mitochondrial Eve would push even farther back in time to their most recent common ancestor with the rest of us. So it's kind of this growing, evolving role that could be much farther back in time than the person we currently have assigned as mitochondrial Eve.
That's kind of cool. Because I heard Eve, and I always think, you think Adam and Eve, and like, oh, that's the generation, that's where we start. And anyway, that's cool that it's scientifically based. A haplogroup, and how can we determine our mitochondrial haplogroup?
Yeah. So that's kind of connected to this mitochondrial family tree that I was just talking about that starts with mitochondrial Eve. And so the haplogroup is basically a series of letters and numbers that is your address in that family tree. So the branch point of you and your closest relatives in this tree starts with your haplogroup. And the way to figure it out is simply to take a mitochondrial DNA test. And so part of the testing process is you'll get a haplogroup, and that's going to give you your place in this family tree and your address of how you relate to mitochondrial Eve and the rest of everybody else who's taken one of these tests.
I know you've kind of asked this already, but how is mitochondrial DNA used for ancestry research?
Yeah, no, that's a great question. It has some really specific strengths for being used for tracing your ancestry. And there's a few really specific challenges for using these kind of tests as well. So as I said before, mitochondrial DNA is only going to be useful for questions that are related to that direct maternal line. So your mother's mother's mother and so on, and kind of tracing that ancestry. I also mentioned it changes very little, and it may not change at all from mother to daughter for many generations. So because of that, a strength is that you can go really far back, and you and somebody who may share like a 10th great grandparent could have the exact same haplogroup. And you can go back thousands of years using this DNA. The problem is because it changes so little, it won't always be immediately obvious how you're related to that person. So you could be related in the same way or share the same type of mitochondrial DNA with a first cousin as you could with an eighth cousin, just because you have that same lineage. So just because you get your matches, it won't always be obvious how you're connected to them because it's your maternal line. And in most Western civilizations, the surname goes with the man. The surname often changes with each generation, that line too, which can add an extra challenge. But basically, the way we overcome that and the way we use these tests is there's two main components to it. When you take a test, you'll get a match list and you'll get a haplogroup, which we talked about already. The match list is going to be all the individuals who share that same direct maternal line. Some of them will be close relatives. Some of them, like I said, may be very distant relatives. but they'll hopefully have information on their profiles that can help you piece together how you might be related to them. The haplogroup is helpful because different haplogroups can be associated with different ethnicities and different geographic regions. Sometimes that can give you a clue. Say if you have a European haplogroup, if you have maybe a Native American haplogroup, something in Asia, that can tell you maybe about the distant origins of where your maternal line came from. Kind of a cool example of this that has been in the headlines recently is they've been doing some of this research in Iceland of researching people's mitochondrial haplogroups. And they have found a haplogroup there that is typically found among Native Americans, which they're still researching to figure out the full implications of that. But one possibility is that that means the Vikings brought back a Native American woman to Iceland thousands of years ago, and she still has descendants in the direct maternal line today, which is something we have no evidence of in the historical record, but DNA is maybe showing us this cool story that history didn't record, but is still being carried in these people's bodies, literally.
That's really cool. So when you were doing, like our tests and we get all these results back, how accurate are they? Because like you said, it's hard to identify like a first cousin from an eighth cousin if they all have the same maternal lineage, right? So you're looking at your mom's sisters, your grandma's sisters, that we're all going to have similar haplogroups, right? So how is the accuracy and how can we use that then to identify who's in our lineage?
Yeah, so I would say the tests are very accurate in assigning the haplogroups. The challenge is that the test itself and the match list is not going to tell you how you're related to them necessarily, other than that you share a common ancestor, which could encompass, your grandma's sister, your third cousin twice removed. You guys could all share a very distant common ancestor, and it will tell you that. It on its own is not going to tell you this is your third cousin twice removed. It's going to tell you you have this many differences between you in terms of mutations or your haplogroup. And so that's where you as the researcher, as the genealogist, get to dig in and be like, okay, I'm looking at your profile now. You have this surname, you're from this area. What are the ways that you could connect to my family tree? And that's where you have to kind of fill in the details yourself with other types of research, because the test alone is not going to tell you more than just this is your common haplogroup and you guys connect at least this far back.
So do you know how far back they can go?
Yeah, all the way back to Mitochondrial Eve, who lived several thousand years ago. And so it'll give you an estimate, and many of these are going to be back, however many thousands of years BCE. Some of them, if you're lucky, will be much more recent. And it'll give you within a range of this many thousand years to this many thousand years, or hundreds of years, if you're lucky and have a more recent one. And so it'll tell you that far back, but it won't, it won't necessarily be exact, this exact year.
That's really cool though. Still, it gives us a lot of places to start for our genealogy research.
Yeah,
so
absolutely.
If people are stuck, this is a good place to go, right?
It is. And a common strategy too, this is often used when you are working on a problem. So say you've got maybe your maternal line back to your second or third great grandparents, in colonial America, where at a certain point, a lot of women's names weren't recorded. You're trying to figure out maybe who her parents were of your third great grandmother. And so maybe you have some different candidate families of she could have been from one of these families. What a lot of people will do to use mitochondrial DNA is they'll test, and then they'll go and they'll try to find descendants in the female line from those other families and invite them to test. And if you guys are a match, that's good evidence that you guys probably were from the same family, and you can then take your family tree a generation farther back. So it's really useful for some of these things of I have this hypothesis, think this family might be connected to my maternal line. So let me go find some other people to test, and let's see if we can either find evidence to support it because it's a match, or maybe they're not a match. And you're like, all right, great. I know that she didn't come from this family. We can rule them out. And I'm going to keep looking for who my real ancestors were.
I like that. So then we gather up a couple people from our family and say, hey, we want to go get our DNA tested for genealogy reasons. Where where do we go? Where's the best place to start? Is there some places that are more accurate than others, or how do you choose the right testing?
Yeah. So currently, I would say FamilyTreeDNA is the best one at present. They're the only ones who offer a dedicated mitochondrial test, and so you're going to get a more recent haplogroup from them. You're going to get a dedicated mitochondrial DNA match list of just your matches from this maternal line. So there's a lot more resources, a lot more support in that sphere. There's a couple other tests that if you take, say, 23andMe's test, or if you take Living DNA's test, they just have their standard DNA tests. Those will give you a haplogroup. And so it'll be, that's this many thousands of years ago. This is how you connect to the family tree, the mitochondrial family tree. So you'll get that information from them. So if all you're interested in is, hey, I just want my address in the mitochondrial family tree, you can get that from those tests. But they're not going to give you the dedicated match lists and that more recent haplogroup that you'll get from FamilyTreeDNA.
Gotcha. So if we want something very specific for the maternal line, we go to FamilyTreeDNA.
Yes, that's right.
And they're great over there. We've met them.
Absolutely.
They're just fantastic people. So it's good to have a good company. So we get a couple people looking in for unknown parentage. We have lots of clients that we help with that. How can mitochondrial DNA testing help us identify a person? Like if someone's looking to see who their biological mother was, or in that instance, how would that be helpful?
Yeah, no, that's a great question. I would say with something that recent, you typically are going to want to start with your standard autosomal DNA test because that is better for estimating how you're related. But it does happen where, your close relatives on that side simply haven't taken that kind of test. And so then mitochondrial DNA can be a good backup because it tells about the direct maternal line, especially if in the course of your other research, you're like, hey, she might be from one of these families. You can invite members of those families who descend in the direct maternal line to test. And if they match you, that can be a good clue that you share that maternal relationship. It can also give some clues, again, because it can give that potential, hey, these are the distant origins of where this came from. It could maybe give some clues if it's a very specific ethnicity of like, oh, this is Jewish, this is Native American, something like that could give you some more clues about who your biological mother was. But again, you're going to want to probably start with your standard autosomal DNA test first and exhaust your research possibilities with that before moving on to mitochondrial DNA.
Awesome. Well, thank you so much for being here. I appreciate all of your help and answering all of our questions.
Well, I had a great time. I'm sure I'll be doing this again in the future. But
I appreciate you. Thank you so much.